So yes, so as Bruno said, I'm filling up for Chris. Unfortunately, could not be with us today. So instead of hearing about microservices, I want to talk about the Java modular system, or in short, the Java PMS platform module system, which I'm pretty sure that some of you have heard of it before since it came out in Java 9. And it's likely that only a handful of you have given a taste because, well, we'll see in a moment what's going to happen. And there is a brand new library out there called Layrry that gives you many of the benefits of turning an application into a modular application instead of just using the regular class path. So my name is Andres Almarai. I'm a former Java champion. I'm Apache Guru PMC. I love talking about open source. I also work for Oracle, and so I prefer to call myself a seasoned sorcerer because I do a lot of open source work, and that's one of the things that we do inside. Anyway, so JPMS stands for the Java Platform Module System. It's also known as Project Jigsaw. It had many years in the making until it was finally released in Java 9 about 3, almost 4 years ago. And the original idea for this project was to break down the JVM monolith into smaller pieces, into easily consumable pieces. And the architects of Java saw that while they were doing this incredible work, the structures that they put in place could certainly help us developers in designing applications. So, well, now we also have the JPMS available in user space. And in theory, JPMS allows to design applications with better encapsulation and design foundation. And I say in theory because it does provide the basis, but there are a few things that happen. So you probably have heard some of these comments from colleagues, from yourself, or from somebody else. So we asked some developers what they think about JPMS, and some of them say, well, JPMS only allows for one version of a module, which is true. The specification says nothing about versioning modules. Also, JPMS doesn't allow adding modules at runtime. So you have to construct, you have to design your application at compile time. You have to define which modules come together and this and that, the requirements, blah, blah, blah. And boom, once you start your application, you're done. You also apparently have to modularize all your dependencies to reap the benefits of JPMS. Now, the advantage of JPMS is that you have a module descriptor. You can define which packages are public, which ones are private, how you export services and whatnot. And if you don't do this, well, then you're missing part of the gains of the encapsulation. So all your dependencies have to switch to the module info or the module descriptor unless you don't get most of the benefits. But that's actually not that true. It's also hard to map dependency coordinates to module dependencies, because another thing that the spec doesn't mention is how we define what is a Java module, how we package that into something that can be easily consumable. For now, it's just a sheer happenstance, a mere coincidence that we have one module per jar. We could have multiples, or we could have it in a different way, but right now it's how it works. And also, of course, well, one of the things that happens with JPMS is that we can no longer have what is known as a split package. We used to ship, in some cases, a package that was that some contents of these classes were provided in one jar file, another one another jar file. And because we assemble everything on the class path where things work, but now with JPMS, a package cannot be split among different modules, among different jar files. So if any of these things that I'm saying, just say today, sound familiar to you, you may be thinking, well, Andres, what about OSGI? Isn't OSGI supposed to fix some of these things? Yes, it does. It kind of does. But today, we're not going to talk about OSGI. We're going to talk about JPMS. So the thing that no one have ever said before is, why did we use the JPMS layer support to fix most of these issues? Now, if you're like me, you may be wondering, what is JPMS layer? Well, if you navigate to the Java doc, then you find this particular type called module layer. Now, the module layer is something that comes from the JVM. This is part of the standard Java library. And it's one of the things that the module system uses in order to construct a class loader. So that from there, the classes belonging to certain modules can be looked up, can be instantiated, and then you do the work. Now, this again is something that is coming already from the core. The API, it's usable, but it's not friendly consumable, perhaps, if I want to say something like this. Say, for example, this is what we have right now. This is the standard layers API. So you create a boot layer, which is the starting point, and you can have another class loader that can be a starting point. We're going to choose a system class loader. And in items number 1 and 2, what we do is we define 2 paths to jar files. Again, we're assuming there's 1 module per jar. So we have here 2 references to something that can potentially give us modules. Then we use the module finder to initiate the search for these modules. Then we create a configuration that is going to resolve the modules. Notice that now in line number 12, we actually make a reference to the module names, no longer the artifact jars. And finally, in step number 4 is where we create the module layer that contains the definitions of these modules. And it's from this module layer that we can bootstrap our application. Now, say, for example, you have an application that looks like this. Let's say it's version 100 of your application. That has some dependencies, module foo and module bar. Both of them depend on log4j. That's quite standard. But notice that foo depends on the greeter module version 1. And bar depends on the greeter module version 2. Now, if we are following semantic versioning, these are likely means there are binary incompatibilities between greeter 1 and greeter 2. Having both of them on the class path will be quite troublesome. Having them both in the module path is also troublesome. So what can we do? And this is where Layrry comes in. This is the URL for the repository. Is a project that was started around late March of this year, and there have been quite a good number of developments since then. The creator is fellow Java champion Gunnar Morlink. He is an open source software engineer working currently at Red Hat. He's the current lead of the vision, and he's also very well known in the Hibernate world. He is also the spec lead for beam validation. And he likes to blog about performance and, of course, Hibernate and the vision. Now, remember what we saw in the previous slide on the API for the module layers. Well, the following thing is what Gunnar said, oh, let's have a better API for this. And looks like this. So this layers API is Fluent interface design. It's kind of like a builder that allows you to define layers. Each one of the layers, you will put the Maven-like coordinates for the jars, for all the artifacts that you want to resolve. And you can compose layers. So say, for example, here we have a base layer, which is the log layer, where we have log4j and some log config module that is specific to our application. Then we have the foo layer that depends on log and that has the greeter module version 1. And then we have the bar layer that also depends on log and has greeter module version 2. And finally, we have the app layer that composes on both foo and bar and adds additional code. This probably contains the launcher. We build the layers, and then from the layers, we run a simple class file. This class file has the main method, and we can pass additional arguments. It's as simple as that. So with this API, then you're more easy. You can consume and you can define layers. But of course, Layrry is just the tip of the iceberg. It's only a thin veil on top of what all the benefits that JPMS can provide. Now, there's one thing to say, this is how I'm going to define the layers. Another thing to say is, well, I want to launch my application. How I can do it? Well, there are a couple of options. So let's see how we can launch Layrry. We can provide our own custom launcher based on the Layrry API. So basically, it's just use that layers builder and in a main class, and then boom, off you go. You can add, you can customize that layers as you want. But given that the structure is so common, we could probably externalize the configuration. Now, if we're looking at different external configuration files, the one that is most popular today is YAML. So the previous definition that we saw earlier, we can transform it into external file, such as layers YAML file, and have the Layrry launcher just consume this file and off you go. But of course, Bruno has something to say about this. Bruno doesn't like YAML. Bruno likes other formats, such as TOML. Well, guess what? Layrry also supports TOML-based configuration. Now, both files have exactly the same layers definition. And Layrry Launcher will be very happy to consume either one or use your own API. You could also provide another external configuration format. Now, Layrry only supports YAML and TOML out of box, but if you want to use JSON, XML, or something else, feel free just to create a module and probably send us a pull request. Now, here's another feature that was available since the early days, and this is probably the feature that sold me into looking further into Layrry. It's not just the fact that there is now a much friendly API to consume modules, but also an API that allows you to add and remove behavior at runtime based on modules. So these are known like a plugin architecture. So Layrry, besides the launcher, it also provides a very thin layer for discovering plugins and adding or removing plugins at runtime. What you have to do as an application developer is define an implementation of this interface. There's only one interface, and that's the only thing that you need to do. Implement this interface, and there you go. Now, typically implementations of this interface will use the service loader to load the types that you want. So when the event of a new plugin has been added, Layrry will trigger this code, and this particular piece of code uses the service loader, finds instances of a specific type. My service class is an application-specific type, and based on every instance that is found, you probably will want to match if it's coming from the layer that defines the dynamic plugins, and that is the case, then you can do something about it. Now, we know about the API. We know about plugin architectures. We also know about the external configuration. Now, some of that external configuration will be quite repetitive. Perhaps is the group IDs, perhaps is the version numbers. Specifically, if we are talking about how do we build these applications, is it Maven, is it Gradle, something else, the definitions of those dependencies will be in the build files, but also have to be in the layers file. And it will be very easy to make a mistake and put the wrong version number. So one thing that the external files supported by Layrry is that you can have parameterization. So let's look at another application here. This is a JavaFX application. And notice that we use a template format here is based on Mustache. It's very simple, very fast. And we have decided to switch all the artifact versions to use the templates. The values of these templates, these placeholders, will come from a secondary file. It's a properties file. You can use any key value combination that you want. And when you pass these to the launcher, you pass the layers and you pass the version numbers, then Layrry will assemble everything together. Here's another thing that also happens, that Layrry will detect the OS properties. And in the case of JavaFX, the JavaFX dependencies have an OS-specific classifier, which does not follow the standard convention. So Layrry has an additional alias for this classifier and is able to launch it. So now I can just define this single file, and it can be used to run on any platform where JavaFX run. It's not specific to Windows, nor Linux, or Mac. It just works. So how do we launch an application like this? Well, you can use the ready-made Layrry launcher. Is a shaded jar that contains all the base dependencies for Layrry to work, and you pass two properties: the location to the layers config file, could be YAML, could be TOML, and the location, this is optional, to the properties, and that can be used for placeholder substitutions. So you can have your Layrry launcher on the command line. You can also build your own custom launcher using the API. Right now, the other thing that you can do is another project called JBank. JBank is it was born based on Java's, I think it was came out in Java 10, JEP 330, launched from source file. So basically, you compile and run a source file on the go. It doesn't add support for dependencies, and that's where JBank comes in. So you define a single source file with all the dependencies, and off you go. Then it grew after. So at the time, it grew beyond what 330 offers, and it also supports Java 8. The point is that what this particular line of code is doing is connecting to the Moditech GitHub organization. This is the GitHub organization that hosts the Layrry project. In that particular organization, there is a very specific Git repository that matches what JBank wants to find. And if it's found, JBank will download some instructions and will allow you to run Layrry locally without having any previous installation of Layrry. You don't have to have the Layrry launcher. You only need to have JBank installed on your system, for which there are many ways to get it installed. Now, I know that I've been talking too much about theory. Let me show you why I'm so excited about this particular feature. So I'm going to jump into the terminal, and I have here an application, and I can show you, let's see what we can do. So this is the application. It's just a standard, either Maven or Gradle application. And we have a few modules, such as the module that contains the model. And let me show you that this has a module descriptor. It's right there. Has a simple package and has a transitive on another external dependency. And here we have another one that looks like this. This is the one that defines most of the behavior, consumes the model package that we defined earlier and makes use of JavaFX. And there's our tile plugin lifecycle listener. This application makes use of dynamic plugins. Now, let me show you the application running. I do have it here on the command before. So going to launch it using a local version of JBank. Notice that I passed two parameters, the location to layers config and the location to the properties. This is exactly the same TOML file for JavaFX that we saw in the slides. So I launched the app, and it will be available in right here. Let me do maybe it's smaller, perhaps. Yeah, like this, and then put the application on top. Here we go. All right. So it's a blank application right now, and what I'm going to do is to start copying plugins from the plugins prepared directory, which is outside of the scope of the application, into the plugins directory, which is a directory that is defined in that configuration file. All right. So let's copy everything together from staging plugins prepare into staging plugins. Boom. You get three elements now. You know that this is live. This is the actual plug that I'm streaming directly from Switzerland. And now I can remove one of those plugins, let's say plugins, and remove the tile that has the gauge, the one in the middle. Oops, that's not the way that we do it. It's not copy, is remove. And there it goes. We can also remove the other one, which is the spark line. And off it goes. Or we can just add them again together. Boom. Dynamic behavior while the application is launched without doing anything extra. Of course, the way that we add and remove plugins could certainly be an application feature, such as I can add a menu here and say, add a jar to my class path, or or install a plugin, or remove a plugin. I will do exactly the same deal. How does it work again? It's thanks to this plugin lifecycle listener. And as I said earlier, it makes use of the service load. What comes inside here is application specific. So in the case of this application, we have something called the plugin registry, which knows how to read the content of the plugin. So this is something that is follows tile plugin. It's again application specific class. And once you get inside your application, you can decide where these things should be created and when these things should be added in the JavaFX application. And if something gets removed, again, the tile plugin lifecycle listener here receives this event and uses that plugin registry application-specific code to remove every plugins that are bound to that particular layer. It's just as simple as that. It's a very simple entry point, but it's very powerful. So, what's coming in the future? We may support remote configuration. So you saw we can launch applications using a local file, but we may in the future support configuring from a remote location. HTTP, HTTPS, whatever it is, as long as it doesn't live inside your local development machine. We're certainly going to make a ready-made binary distribution. So for now, you have to build a Layrry yourself. And there will be a release pretty soon. We're just ironing the latest details to get the next alpha out. There will be, of course, different distribution channels. You may be able to download the releases directly from the GitHub page. We may post it to Homebrew. We may post it to SDKman or any other package manager that makes sense. Gunnar wrote a couple of blog posts announcing Layrry. That's the first one. Then the second one is describing further the plugin architecture. And the last one, this is something also quite interesting, is if we are loading and unloading classes in plugin architecture, it's likely that we might have memory leaks because, well, there may be dangling pointers to classes. And as it turns out, we had a memory leak in this JavaFX application that I showed you. But besides unloading and loading of classes, Layrry also registers JFR, Java Flight Recorded Events, that can be monitored through the mission control. And in the third blog post, that's how Gunnar goes through testing these applications. And that's how he was able to find that we had a memory leak because there was a dangling thread somewhere in the plugins. Once we pinpointed where was the problem, we remove it, and then everything was working. And it's all thanks that Layrry is friendly to monitoring. The GitHub page for the project is right there. It's Moditech Layrry. The JavaFX example is readily available in the Layrry examples. There are instructions that tell you how you can run it yourself. There's another example using Vertex, also dynamic plugins. So Layrry is not just for JavaFX, it's for any kind of application that you want to have with modular systems and any application that may want to have dynamic plugin support as well. So everything that we saw today is open source. If you have not contributed to open source before, let me tell you, it's quite simple. You see any problem with what we saw today or the open source project that you have to work in your daily day, open a ticket. And that's it. Let the team on the other side know that something is wrong and maybe there's a missing feature. You don't have to send code. You don't have to send a patch. But if you want to, yes, certainly will be very welcome. But at the very least, just open a ticket, engage in a conversation with the team on the other side of the wire. And I believe that's everything that I have for you now. And if there are any questions, well, I'll be very happy to take them. Bruno.
Hey, Andres. This is amazing, man.
I know, right?
You did a TOML talk. Amazing. I love it.
Yes.
I love that. Let's see if we have a few questions online. I don't think we got anything. I'm just going to double check on YouTube. Nope. Layrry and JPMS, I think JPMS is complex for the average Java developer, right? Or even for experienced Java developers, it is complex. I think Layrry is the kind of thing that perhaps the OpenJDK team thought would happen if they didn't build that themselves. So I think it's interesting when people think, oh, we should have this functionality on OpenJDK itself, and sometimes actually OpenJDK, you only have the bare minimum components. And that is, if we look throughout the history of Java, that's what actually makes a Java ecosystem strong, because OpenJDK only brings the bare minimum components. And then you have this huge ecosystem of tools and libraries and things that people build on top of it to make it interesting. And that's what makes it so vibrant and so diverse in terms of like ideas coming from different places, from different engineers, and so on. So Layrry is the the perfect example of that in recent times. We have a functionality that is not great for end users. JPMS is not great for end users. It's there, it works, but Layrry makes it actually interesting for end user developers who are building business applications. The JavaFX example is a great one that shows how powerful the modular system is once you
Right.
have something like Layrry.
Yeah, exactly. So at first, like many others, I was puzzled by how little the specification for modules defined. So we knew before that it came out that there were questions about versioning modules and dependencies and a few other things. And once you look at the specifications, that there's nothing there. So what's going on? Is this going to be usable? But the designers decided to add just the bare minimum, just enough, so that they did not constrain themselves to certain paths. So things like Layrry, and there may be another library, I don't know, it's very open. Someone can build something on top of JPMS and provide all those missing features and additional capabilities because the space is very wide open.
Yeah. And what do you think is the next step for Layrry when it comes to libraries? Do you expect libraries to come ready to be consumed through Layrry? Because we've been seeing some libraries coming with module definitions and so on. How does that apply to Layrry?
Well, I would probably expect that an application framework could arise. It could be generic application framework that simplifies how to deal with dynamic plugins. It could be a JavaFX powered application framework that it's more specific to that particular use case. Just because, well, again, as I said, if you have a menu, if you already have something like a workbench, so similar to what we understand now from ITEs, and some sort of a download, an update feature, yes, I can certainly see that happening. Some of the things that we're thinking in the future, so I mentioned the remote layer capabilities that will allow you to have a local installation of Layrry or even just use JBank and consume something that is outside of somewhere else. And that sounds a little bit like Webstack, isn't it? Yes, exactly. That's one thing. The other thing is launching a Layrry application within the same J-Link image. So all your modules will probably exist within the image. You may want to have that, or you also want to combine inside image modules with external modules, which, by the way, right now they are resolved using Maven, which can be configured externally. But what if you also want to have a sandbox for all the dependencies? So you don't want to have any relationship with Maven resolution. You will want to point Layrry to a directory where all the dependencies live. Well, there's already a PR for that. So we have that feature. It's almost ready to be consumable to everybody. And like these ideas, what we expect is people from the outside to test out Layrry and give us feedback on all other use cases that we have not thought yet. And let's see how we can come up together. And perhaps there's something that we can add to the core. Or maybe it's an idiom that we can tell to the users, just follow that path because it's specific to your use case, but it's still very valid, of course.
What do you think? What do you think Java EE application server would look like if it was done from scratch using these technologies today?
The trick would be CDI, I suppose.
CDI, okay. That's the only possible issue.
CDI would be the only possible issue, I believe. And so we have seen a shift now with Micronaut and Quarkus to do compile time injection. And that is perfect for JPMS when you don't have any dynamic plugin support in the application. But if you add that, then how do you resolve any dependencies that had to be added to the types that had just been loaded? So for that case, you still have to use dynamic dependency injection. And then right now, neither Micronaut nor Quarkus support that particular use case.
Okay, that gets tricky. I was I was only going with the idea of like replacing class loading challenges with Layrry, but I guess that's not the only problem.
No, it's not the only thing.
Okay, sounds good. All right. Thank you so much, Andres, again. Here's the thing. I would like to invite you, if you're available, to come back in about 15 minutes to have a chat with me and Kirk after we have the GitHub for Java developer session. Are you on board with that?
Sure, no problem.
Okay, so 15 minutes from now after GitHub for Java developers, and then you come in and then we chat for more 15 minutes. So how about we go, thanks, Andres.